Alright, if you're checking out this video, chances are you had some questions about 4, 5, and 6 and 7 on 5.10. So I figured I'd go through these examples with you. You'll notice I already did a little bit of work here. That's just to save us some time a little bit. Alright, so starting with number 4. Now what we're supposed to do is write each equation in slope-intercept form, and based on the slope-intercept form of each equation, determine whether they have 0, 1, or infinite solutions. And how do we know? Let's take a look at 4 here. You'll notice I already put the first equation in the slope-intercept form. Second one's already there. Now, I don't even have to graph this, but I do have a graph here just to demonstrate why. And now I look at it, I probably should have gone a little bit higher, but that's okay. But you know what? I'll explain it. Either way, let's take a look here. Now, the first one we have is y equals negative 3x minus 7. So I can go to minus 7 here. I'm going to go backwards, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, and I can make a nice little line out of this. Okay. Now, for the next line, you'll notice what I'm going to do here. I'm going to do something a little out of the norm. Since I have 13 here, can't graph it on what I have here. I'm just going to change it. I'm just going to make it up here. I'm going to give something a little bit easier just to demonstrate my point. I'll make this 5. I'll illustrate my point a little bit. So I can go up 3 over 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3. All right. You will end up having something that looked like this anyway if you used a different y-intercept. So the y-intercept doesn't really matter in the explanation here. What you'll notice, however, is these two equations in this system have different slopes, 3/4 and negative 3. Since they have different slopes, you know, since this one's 3/4, it's going to be going up. The one that's negative 3, it's going to be going down. Since they're going in different directions, they're eventually going to meet and cross somewhere. So the key is, if your equations have different slopes, that means eventually those lines are going to cross somewhere. In this case, they crossed right here. Might not always be a perfect point. Chances are it might not be in a lot of cases. But the goal is you want to recognize that if you have different slopes, eventually those lines will cross. Even say, I'm going to try and move this. Is it going to work? Whoops. All right, that's all right. We're going to use something to prove a point here. These were both, one was positive, one was negative. Say they were both positive. I'll just randomly make up a line here. There we go. This one has a positive slope since it's going up. Guess what? They're still going to cross. So even if they are both positive or they're both negative, they're going to cross at some point as long as the slopes are different. So if they have different slopes, they're always going to have one solution. And how do I know? Different slopes. So let's carry that information over a little bit here. Now I get to this equation here, and you know what? I didn't put it in the slope-intercept form. I really should have. You'll notice that the first thing I did was I divided the top one by 3, and I ended up with the same equation. So guess what? If I put one in the slope-intercept form, it's going to be the same thing for the other one. So I'm going to subtract x on each side. Notice how I write down my steps here. It's always good to get into the habit of doing that. A lot of times people try to do it in their heads. And they're like, I don't want to write stuff down. But guess what? Chances are you're going to make a mistake if that happens. So it's always good to cover yourself. I've been teaching math a long time, and I still write out my steps. All right, so I get y equals x minus 1, which means, hey, if this one is y equals x minus 1, we get the same thing here because they're the same equation, which means I'm going to get the same line. So let's see if I graph this. Oh, should be negative 1 for my y-intercept. It's okay, mistakes aren't a bad thing as long as you catch them. I think it's healthy to see someone make a mistake and then fix it. All right. So hey, I get the same line here. How many points are on one line? An infinite amount. This line literally goes on forever. So that means this line goes on forever, got an infinite number of possible points. So guess what? How many solutions does this have? Infinite. Put an exclamation point. How do I know? Same equation, which also means same line. So anytime you get the same equation, guess what? They're going to give you the same line, and the same line is going to give you infinite possibilities. So anytime you get two equations that simplify into the same equation, you're going to have infinite solutions. All right, so now we get to this one here. Oops, again, we have a crazy number here of 30. Now, for the sake of what I'm doing, the y-intercept really doesn't matter. So I'm going to get rid of the 0 here just to make this a little easier to graph. All right, so I got two equations here. I put them in the slope-intercept form. And again, you'll notice I knocked off the zeros. Reason is, I just want to be able to graph them to show you something. So I'm going to go up to 3 here, go up 1 over 2, 1 over 2, keep going. Hey, what do you know? Boom, got a nice little line here. Let's do the other one here. Oh, all right, so this one would be -3. Going to go down to -3, up 1 over 2, up 1 over 2. Hey, wait a second. Watch what happens when I graph these. Might notice something about your lines here. They are parallel. Guess what? Do parallel lines ever meet? No, they don't. Parallel lines never meet, which means there's not going to be a point where they cross. Which means if there's not a point they cross, they don't have any points in common. Which means there are no x's and y's they have in common. So how many solutions does this have? 0. How do I know? Same slope, different y-intercept, equals parallel lines. Two L's in parallel. Two L's are parallel. What do you know? All right. And then you get to 7 here. I solved this using elimination. I really should have put it in the slope-intercept form, but that's okay. Hopefully you did that. Hopefully you followed directions. But I solved it by elimination just so I could make a point here. When I solved it using elimination, I got one possible y value and one possible x, which means that there's only one possible y and that one possible x, that is only one place where these are going to cross, and that is at -2, and is that -3? Whoops. No biggie. Yep, -2, -3. So that means I'll be honest with you, I don't know where those lines go. They could be going like this. Hopefully you guys followed directions. Mr. Gamache didn't. What that means is, regardless of what these lines look like, they're going to cross at that point. So that would be one solution. And chances are, if you simplified it, unlike Mr. Gamache, put it in the slope-intercept form, you'll notice that they have different slopes. So what are we pulling from this? If you get a system with different slopes, you're only going to have one solution, because that means those lines will cross at one place. If you get a system where they simplify to the same equation, you're going to have infinite solutions. Why? It's the same equation, which means the same line. Same line means infinite points are going to be on that line. If they're parallel, 0 solutions. Why? Well, they have the same slope, which means they are never going to meet. All that space in here is going to exist, and these lines will never cross, which means there will be no solution to this. Hopefully this helped you out a little bit with 4, 5, 6, and 7.